Hey guys, in my latest video I showed you how to make a destructible terrain using the geometry class, and today I want to take a deeper look at this awesome class. Quick note, I'll focus only on 2D operations now, but you should know that the geometry class also has some nice 3D features. So without further ado, let's get started. The first thing I want to talk about is Boolean operations on polygons. I used it in my previous video to make the difference between two polygons, but you can also do intersection, union, and XOR. As you can see, I made a small demo with all the operations and also some other features. I'll talk about them later. To use these operations, it's pretty simple. For each of them, you provide a polygon A and B, and the result is given in an array, even if there's only one result. Depending on the operation, you might have more than one result. For example, if you want to make the difference between two polygons with one inside the other, you'll have two results. One will be the outer polygon and the other will be the whole. You can check the nature of the polygon by using isPolygon_clockwise. If the result is true, you know it's the whole. And with that, you can do all sorts of operations on polygons and use the result for both Polygon 2D and collision polygon. You have to make sure you take into account the offset of your polygon, though, as I pointed out in my previous video, the function takes only the polygon points, and thus it will not take into account your node's transform by default, so you have to do it yourself. In my latest video, I asked if someone had a better solution, and Alfonso commented and gave a quick way to do it using poly.globalTransform.xform poly.polygon. He explained that xform takes a variant as an argument, which can be a pool vector 2 array, which is the data type used for polygons. And with that, we have a nice one-liner solution. Thanks, Alfonso. In my example, you can see that I'm not offsetting the polygon's value. This is because both of my polygons have the same location. The second thing I want to talk about is the ability to check if a point is inside something. We have three functions available: is inside polygon, is inside circle, and point is inside triangle. Those are very similar and you probably could use the first one for everything, but they exist for your convenience and the data you have available. I show these three in my demo. For the first one, you simply provide the points and the polygon's data. For the second one, you use the circle position and radius instead of the polygon, and finally for the triangle, you must pass the 3 points defining your triangle. Each function will return you a boolean telling you if the point is inside or not. You have to make sure the point is matching the transform of the polygon, circle or triangle. So for example, with isPoint in polygon and point is inside triangle, I converted the global position of the point to the target local position. So the polygon called shape A and the triangle called shape triangle. For the circle, I use both global position for the point and the circle center. These functions are really useful for some specific use case. A good example is checking if a character is inside a collision shape without using an area, for example. In my case, I used it in my latest video when making the destructible terrain. In the projectile path visualization, each step along the path creation, I'm checking if the point I just calculated is inside the terrain polygon. If it's the case, I know I should stop drawing the trajectory because I hit the terrain. One last example before moving on to the next functions. During my 12 prototypes challenge, I made a little game called Snake. You have to encircle food to get it. To check if the food was inside, I created a collision polygon using the line to the points I created and check the presence using the area signal. As you can see, it creates a microstutter with the creation taking from 11,000 microseconds to more than 270,000. In contrast, if I create a polygon 2D using the line to the points and check the presence of all foods using isPoint in polygon, it doesn't take more than 468 microseconds to check, which is much faster. The third thing the geometry class can do is tell you where the closest point on a segment is, whether it's from a point or another segment. Let me demonstrate how it works first, and then I tell you how it can be useful in some games. The first function, getClosestPoint to segment 2D, takes the position of your point and 2 points defining a segment. In this case, I'm using the 2 points of a line 2D I use to visualize the segment. The second function, getClosestPoints between segments 2D, will take 4 parameters, which corresponds to the 4 points defining the 2 segments. This returns an array with 2 points, one for each segment. Again, make sure they have the same base when comparing position. For the first one, I'm using the local position because they have the same origin. You could use the global position instead to take into account any transformation. In the second function, you can see I'm transforming every point to global because I want to take into account the transform of the second segment, which is moving. Note that there is another version of this function which uses the definition of a line instead of a segment, so you provide a position and a direction. A line is infinite, whereas a segment is defined by 2 points. These functions might seem very specific, and they are in fact, but I think you can find more uses than you might initially think of. For example, in a 2D skate game, you might want to grind on a rail, and with this function, you can get the closest point to the rail and attach to it correctly. The fourth thing the geometry class can do is give you the intersection point from segment to segment, or from segment to a circle. To use segment intersect segment 2D, you simply provide the 4 point defining the two segments, just like we did previously. This gives you a resulting point, but be careful because it can be null if the two segments are not intersecting. For segment intersect circle, you provide the 2 points for the segment and the position and radius of the circle. Note that there's no function to intersect with a polygon, but you can emulate that by taking each pair of points inside the polygon and use the segment intersect segment 2D function. And to finish this video, I'll talk about two last functions that don't really fit in a category. The first one is offset polygon 2D. This is useful to change the size of your polygon without using the scale. Using the scale won't change the points, and thus you'll have to offset them manually before doing any calculations. And finally, the last function is called triangulate delineate 2D. You simply provide a polygon and the function gives you back an array of points. Every 3 points defined a triangle. It can be really useful to create destructible stuff in 2D. I think I saw an add-on that was using that to create the pieces when a sprite was destroyed. That for all sorts of things. It's a very versatile function. And guys, that's the end of the video. I hope you liked it. I think this class is totally underrated and can be useful for so many things, especially if you're trying to tinker a bit with Godot. I only covered the 2D aspect of the class, so if you want me to cover 3D, please let me know in the comments below. As always, you can find all the sources in the description and even try the little demo I showed you on screen on itch. If you want to support me, you can wishlist Dashpong, the local multiplayer game I'm currently working on. If you want more, you can follow me on Twitter, Instagram, and join the Discord. I'll see you soon, and in the meantime, have a great day. Bye!